This is the second video of what we would have done today. This has to do with friction. Now there are three main kinds of friction: static, sliding, and rolling. And there's also fluid friction, which has to do with when you have a fluid layer. That I think is pretty easy. I think you can understand that if you have a fluid in there, it makes things slippery. Depending upon the viscosity of the fluid, you may have more or less friction. Don't overthink that. But people often have a problem between these three, which I think, again, they're trying to overthink it. Okay? Static friction. Static means still. Something that is still. Remember, we need to apply an unbalanced force to make it unstill. So I'm pushing on this ball. But the ball's not moving. That's because there's another force that's opposing my pushing. And remember that that is friction. But now we can say exactly what kind of friction is going to be opposing me trying to get this ball moving. So something that is still, and you want to make it unstill, you want to make it move, you have to overcome static friction. Static friction tries to prevent the motion in the first place. So something that is static, you want to make it move, you want to make it unstatic, you have to overcome static friction. So if I push this hard enough, I will overcome static friction, and it will start to roll. But notice that it will eventually stop rolling. That's because once it starts rolling, there is another kind of friction in the work, and that is rolling friction. In rolling friction, something that is already rolling, the static will try to stop that rolling. So static, something is still, you want to make it unstill, you overcome static friction. Rolling friction, once something is already rolling, rolling friction will try to stop the rolling. I have to overcome static friction to get the ball rolling in the first place. But then rolling friction takes over and will eventually stop the rolling. Sliding friction is basically the same thing, just with an object that's already sliding. So I have a cork on a styrofoam tray. I'm going to lift it to a small angle, and it's not moving. Why isn't it moving? Because there's static friction between the cork and the tray. I have to overcome that static friction in order to start the cork sliding. So I'm going to keep this rising, and then eventually it will start to slide. Okay? Now in this case, it stopped sliding just because it hit the end of the tray. So let me do that on the table like I did the ball. Okay? So the cork is now still. It is static. It's not moving. If I give it a little push, it's not moving because of static friction. So I'm going to give it a bigger push, and it's going to start sliding. Okay? So I've overcome static friction. I've got it to start moving. But it will eventually stop moving because once it starts sliding, sliding friction takes over. Sliding friction opposes the sliding. It will stop the sliding. So I have to overcome static friction to get it moving in the first place, and then it's going to start sliding. But as soon as it starts sliding, the sliding friction opposes the sliding and will eventually stop that sliding.